Hello students, today's topic is electric power. Let's suppose that there is a conductor which is having the resistance R and the current I is flowing through it, right? Now when the current is flowing through the conductor, we will say that work is done, right? So here charges are moving in the sense that we will say that work is done. Okay, you know that the definition for the power is what? That is the rate at which the work is done. Rate of doing work is called as power. But here we have electric power. So here I can define the term electric power is the electrical work done. So electric power is electric power is electrical work done. Electrical work done. Got the point? Now this electric power that is work done divided by time. Symbolically I can write P is equal to W divided by T. Now the unit for the power, the electric power, is watt. The SI unit of electric power is watt, denoted by the letter, that is capital letter W. Now what about the 1 watt? The power is said to be, the electric power is said to be 1 watt when 1 joule of work is done per second. When 1 joule of work is done per second, we will call that one as the electric power as 1 watt. Now this one 1 watt is the smaller unit for the electric power. The bigger unit for electric power is kilowatt, that is kW, kilowatt. It is the bigger unit for the power. Okay, now this electric power, as I told you, it is the electrical work done. It is the electrical work done, that is called as electric power. Now work is done, it means whatever the electrical energy is there, it is used up, it is consumed up, right? Here current is flowing. First I said that one, it is nothing but the electrical work done, right? Now whatever the amount of electric current is flowing, that is the work done, that amount of energy is consumed, it is utilized. Okay, so here electric power, it can also be defined in other way, that electric power is the rate at which the electrical energy is consumed. The rate at which the electrical energy is consumed is called as electric power. This is the second definition for the electric power. Okay, now here the electric power formula I have written P is equal to W divided by T. But we know that W is equal to V into I into T. From the heating effect of electric current, this one expression, we know this one. What is the work done? Means W is equal to V into I into T. Now put this one value in the above formula, that is P is equal to V into I into T divided by T. This one T, both are get cancels together. So P is equal to V into I. So here we got the one more formula for the electric power, that is P is equal to V into I. We can say that one electric power, it is the product of voltage and the current. Okay. By Ohm's law, we have V is equal to I into R. By Ohm's law, we have V is equal to I into R. Right? Now put the value of this one V in the above expression. Okay, let's call this one as expression 1. Now this expression 1 implies that P is equal to, in place of V I have to write I into R. This I as it is. So therefore P is equal to I square into R. So this is the second expression for the power, that is the electric power. Electric power, it is the product of square of the electric current into resistance. Similarly, we know that current by the Ohm's law. By Ohm's law, I can write I is equal to V into I. Okay. Now put this one value of I in the above expression, that is expression number 1. So expression 1 implies that P as it is, this V also as it is. In place of I need to fill the value V by R. V by R. Okay. Now this is equal to, P is equal to V into V is V square divided by R. So hence we got the one more expression, that is P is equal to V square divided by R. So here one relation I will tell you between the power and the resistance. The power and the resistance, power in the sense here electric power. The electric power and the resistance, these two quantities are inversely proportional to each other. These two quantities are inversely proportional to each other, which means if the electric power increases, the resistance decreases. Okay, or if we have increased the resistance, the power decreases. So this relation between electric power and the resistance we have to remember. Okay, right. Now as I have written, electric power is equal to work done divided by time. Now this one work done, it is nothing but the electrical consumption, right? So here this electric power, it is equal to, in place of work done I can write electrical consumption or electric consumption, that how much electrical energy is used divided by time. Symbolically, that is P is equal to I divided by time. Therefore E is equal to P into T. So here we got the one more formula, that is the electrical consumption, how much electrical energy is used, that is equal to power, electric power into time. So these are the four formulas, that is first one second one, third one, fourth, and the fifth one. These are the 5 formulas we need to be remember in terms of the topic, that is electric power. These formulas are very helpful to solve the numerical problem. Okay, right. Thank you.